Number 11 asks, consider the figure below. Now, the figure shows a man hanging from a wire stretched between 2 points. And the part A says, find the tension in each cable supporting the 700 Newton cat burglar. Assume the angle theta of the inclined cable is 32 degrees. So you need to find the force of the inclined cable, the tension force of the horizontal cable, and the tension force of the vertical cable. Now, I didn't download this picture, but this is basically what it looks like. You have a block wall, and then you have this other cable attached up here, and this man is hanging, and there we go. He's hanging on to this string, and there's this angle right here that it says is 32 degrees. And so it wants the force, or I'm guessing it wants the tension. So we'll call this T1, call this T2. It wants the tension of the inclined angle, the tension of the horizontal cable, and the tension of the vertical cable. And so what we have to do is we have to set an X and Y axis. So we're going to call this one our Y axis. So T3 and is going to be even with the Y axis. T1 is going to be even with the X axis. So that's X, that's Y. And now, so because angles are opposite each other, this is the same as our angle theta right there. And what we want to do is figure out, okay, so we know on the x-axis we have the tension of T1. So on our x-axis we've got T1, and it's pulling in that direction. Then we've got this a force right here that is, so if we know what T2 is, so T2, and this is the opposite side of our angle theta, so T2 times sine theta, so our second x component, so we'll say our second x component is T2 times sine theta. And so let's see, do we have any other x components? I can't see any. So, and this is acting in this direction. So we know that since there's no movement, the sum of our x values has to equal 0. So that means that T2 sine, let me undo that, sine theta minus T1 equals 0. And so that we're going to call this equation number 1. This is equation number 1. Now we have to add up all of our y components. And so we have a y component going straight down, and it's 700 newtons. And we have a resistive up component, so a tension force, and it's held together all by itself by T2, so T1 doesn't contribute to it. So this is the opposite. Now, actually, now that I'm saying that, I believe that this should be cosine. And you'll see cosine is adjacent over hypotenuse. And so this opposite over hypotenuse is going to be my y. So my y1 is just simply 700 newtons. My y2 is going to oppose the 700 newtons, and it is going to be the T2 times sine theta. So this is T2 sine theta. Okay, so, and this looks so ugly now, I just want to rewrite it as T2 cosine theta. And so then this also has to change. Okay, now we can say that the sum of the y's, the sum of y has to equal 0. And so we can say that this T2, since it's going in the up direction, we're going to use that as our positive. So we can say that T2 sine theta minus 700 equals 0. So this is going to be equation number 2. And so we can actually solve for T2 right here, because, fairly simply, add your 700 to the opposite side, so 700 equals T2 sine theta, and sine of theta, theta being 32 degrees, sine of 32 degrees is 0.529. So what we have now is 0.529 T2 equals 700. So I divide both sides by 0.529, and I get that T2 equals, divided by 0.529, equals 1320. We're just going to round 1321. T2 equals 1321. So because we've solved, that's the inclined cable. Remember, T2 is our inclined cable. So we've already solved our inclined cable. And in order to solve our horizontal cable, we simply plug T2 in right here and solve for T1. So 1320 cosine of 32 equals 1119. So if I add my T1 to that side, T1 equals 1119.42. So T1 equals 1119.42 newtons. And so, and then the horizontal, or the vertical cable, we already said because he's a 700 Newton burglar, it's going to be, the T3 is going to be equal to 700. So T2, T1, T2, T3 have all been solved. Now part B asks, suppose the horizontal cable were reattached higher up on the wall. Would the tension in the inclined cable increase, decrease, or stay the same? So here's what it's asking. We have it's asking if we raise this up, what will happen to the tension right here? So let's reason this out really quick. What happens if we leave this down and we bring this up? Well, then by bringing this side up, let's go back to our y2. So T2 sine theta. So the theta would decrease. So remember, I just want to reset this up. T2 sine theta equaled 700 newtons. Okay, so what happens if this number gets smaller? If the sine theta decreases, that means T2 equals 700 over a smaller number. So if remember, sine theta was close to 0.5, so it doubled the 700 to make T2. What if sine theta was closer to 0.1? It would make T2 7,000. So the smaller this angle gets, the higher T2 tension is. If we decrease this angle, or if we increase this angle, so if sine theta gets larger, then the tension on T2 will go down. So by raising this up, we can straighten this out and decrease the angle, or increase the angle on T2, and so it would take the tension on T2 down. So in other words, if your question says, suppose the horizontal cable were reattached higher on the wall, so suppose the horizontal cable were reattached higher on the wall, would the tension in the inclined cable increase, decrease, or stay the same? It would decrease. It would lower the tension of the inclined angle.